Hello guys, this is Viras Rankure. Currently I am studying in Masters of Mechanical Engineering in University of Wollongong. Today I will present my thesis topic for Engineering 955, the production of multilayer alloy plates. So here is my research plan in which introduction, literature review, research design and conclusion. So first of all, we need to understand what is a multilayer alloy plate. So first of all, we will go through the applications. Multilayer alloy plates are used in critical applications such as aerospace, power generation, and medical equipments. And multilayer alloy plates is a deposition of same alloy or a different alloy at a different or same thickness on one another by using the advanced manufacturing methods. There are several methods which employed for the production of multilayer plates, in which surface cladding, surface coating, welding, but they have their limitations and drawbacks. So there is another method we propose, the additive manufacturing process, in which the selective laser melting shown good results. However, it also has some issues with soil deposition defects, porosity, residual stresses, and lower surface quality. So overcome to these SLM issues, we proposed the selective laser manufacturing, and then powder-based friction stir additive manufacturing, which is also known as FSAM. FSAM is a combination of friction stir processing and additive manufacturing, which offers improved mechanical and microstructural properties in aluminum alloy. FSM is a solid state process which does not emit emissions, does not require shielding gas, and a consumable tool. It some has challenge related fixture design, temperature gradient, the effectiveness of tool. Also, FSM is getting more attention these days due to the potential application in engineering and medical devices. As there are, take for example, as there are material like aluminum, which has some properties which cannot be employed for the other methods. However, FSM does not emit melting heat up to the melting. So we can use friction stir to produce plates regarding aluminum alloy. Also, FSM has received laboratory validation and is being used for these materials: titanium, magnesium, aluminum, copper, and steel alloy. But as we know, it needs some research and needs some publication to fully explore its capabilities and application. So here is my literature review. First of all, we will understand what factors affects or limits the wide application of FSAM, in which we included tool pin, pin diameter, pin length, profile, which affects the material flow and the surface texture and surface quality as well. Also, apart from that, material properties such as type, thickness, and it get influenced by the process parameters. After that, the machining factors, in which tool orientation and material related factors. So there are some researchers who invested their time to understand the FSAM on extensive level, in which Zhang investigated the use of FSAM with regarding the high strength aluminum with aluminum 6061, and it showed reduced grain size and temperature effects. So the Delhi firm developed the friction free form fabrication, which also improved the mechanical strength and mechanical properties of the aluminum. Apart from that, Mondal studied aluminum 106, which is low strength steel, and found improved strength, ductility, grain refinement. Apart from that, the Philip examined the high strength aluminum and observed significant grain size reduction and deformation characteristics. Then Zhai employed the laser melting deposition along with friction stir processing to create nanostructured iron chromium silicon alloy layer, showing changes in hardness and modulus of elasticity. Then Lee deposited pure aluminum powder on titanium alloy, resulting the titanium alloy composite structure. Then Palaniwal investigated the multi-layered magnesium-based alloy using friction stir additive manufacturing and explored its potential application in aircraft components and stringer topologies. So this is my research question. Extensive research over the friction stir additive manufacturing process and investigation of process parameters such as tooling parameters, microstructural and mechanical properties of material and machines for a wide range of applications, such as general material joining and the welding that can make this process easily accessible. And these are my learning objective is understanding the additive manufacturing to produce multi-layer aluminum alloy plates, understanding the tooling, microstructural, and morphological parameters for the specific alloy to achieve the desired results. This is my research design in which we proposed three layers of manufacturing of multi-layer aluminum plate in which first of all I'll introduce the conical tool, and we propose one duct to provide additive powder instead of giving that duct inside the tool. So these are the process parameters we used for this. It's atomized pure aluminum powder with a particle size ranging from 50 to 300 micrometer was used, and the powder composition is 2.58% oxygen and 97.42% aluminum by weight. Then additive free surface processing was performed using vertical milling machine. As we can see in the figure, there is a tool which is operated by a milling machine and the duct for the flow of additive powder. And the layer was created on the 30 mm thick metal substrate using additive friction stir processing tool made of tool material is steel. Then powder pouring method, powder was poured in front of the tool and compress was used to maintain the continuous powder flow. The proper spacing between the tool and the substrate layer resulted in the increase in layer thickness. Then heat generated by friction between the tool and powder caused plasticization and the layer development. The layer thickness achieved was 0.5 mm. And the 3D structure was fabricated with the dimension of 7 mm in height, 62 mm in length, and 16 mm in width. Process variables are spindle speed 1700 rpm, then tool traverse speed is 22 mm per minute. Filler powder was provided externally through the extra dot. The results of this test are elemental analysis resulted improved the mechanical properties, including 36% increase in ultimate tensile strength, 3% increase in yield strength, 54% increase in elongation rate compared to the base metal. Then grain refinement was observed with equal dimension and length. Wicker hardness was measured to be 18.5 and 18. It reduced because of some voids has been seen. Then the study identified that the need of further research with a different material, particularly because this study is undertaken with a low strength aluminum, but author much more keen to use this method for the high strength aluminum like aluminum 6061 to explore the full potential of this procedure. Process parameters such as tool feed rate, deposition material properties, and the machine feed rate were found to be influenced by these parameters. This is the research design varied the parameters including indicating the need of tailored procedure for the different materials. Here I'll conclude. Definitely extensive experimentation in friction stir additive measuring is necessary to determine the optimal procedure for various metals, because we cannot consider it a single process parameter for all the materials or all the machine types. So we need to do extensive research and experimentation to understand which process parameter is particularly aligned with material. Then process parameters such as tool feed rate, deposition material properties, and the machine feed rate were found to be influenced by these parameters. The research designs varied the parameters indicating the need of tailored procedure and different materials. And definitely the extensive experimentation in friction stir additive manufacturing is necessary to determine the optimal process for various materials. Thank you.